Dear students, Assalamu alaikum. Welcome to this channel. Dear student, in the previous lecture, we studied about the electrostatic force when there was no medium between the charges. Now, what happens when certain medium is present between the charges? So, our today's topic is the Coulomb's law in material media. Dear students, when there was vacuum between the charges, that is when there was no medium between the charges, we have a formula for that. F is equal to 1 over 4 pi epsilon naught Q1 Q2 over R square. This was the formula for the electrostatic force between two point charges when there was no medium. You know about this epsilon naught. What was epsilon naught? Epsilon naught was permittivity of free space. This was the property of the free space, vacuum. So I write this formula for vacuum, so I just write vacuum as a subscript of this force. So F vacuum is 1 over 4 pi epsilon naught Q1 Q2 over R square. Now what is permittivity? In the previous lecture, we discussed that. What is permittivity? Permittivity is the property of the medium which comes from the word permit. So if I define this permittivity, which is the property of the medium, as the property of the medium which affects the electrostatic force, the magnitude of electrostatic force between the charges. This is the property of the medium, permittivity. Now, if we are introducing a medium between the charges, then that medium has its own permittivity. Let's suppose if epsilon, which is epsilon naught, that is for permittivity of free space, and epsilon is the permittivity of the medium. Permittivity of the medium which we are using. Usually we call this permittivity as absolute permittivity. This is also known as absolute permittivity. So epsilon is the permittivity of the medium. This is the formula when there was vacuum between the charges. Now if we want to write the formula for the electrostatic force when there is certain medium having permittivity epsilon between the charges, then that formula takes the form F medium, MED stands for medium, is equal to 1 over 4 pi, yes, at the place of epsilon naught, this time we'll write epsilon, the permittivity of the medium. And here the epsilon naught was permittivity of free space. Now as that electrostatic force is between the charges between the medium, so 1 over 4 pi epsilon Q1 Q2 over R square. So this is the formula of the electrostatic force when there is certain medium between the charges. And the permittivity of that medium is epsilon. Let me call this equation as equation 4 if we connect this with the previous lecture, and this is equation 5. Now this epsilon, the permittivity of the medium, we usually don't use this epsilon. Instead, we use another term for this, and that term is called relative permittivity. We represent this by epsilon r. This is relative permittivity. And there is another name for this constant, also known as dielectric constant. In physics, we usually don't use these words, relative permittivity. Instead, we use dielectric constant, represented by epsilon r. So if we define this epsilon r, the relative permittivity, this comes out as epsilon r, the relative permittivity, is equal to absolute permittivity. So what is absolute permittivity? That is the permittivity of the medium. It's also known as absolute permittivity divided by the permittivity of free space. That is, if we compare the permittivity of that medium with the permittivity of vacuum, then this would be the epsilon r, the dielectric constant of that medium. So from this, epsilon r is equal to absolute permittivity is epsilon, and permittivity of free space is epsilon r. So can you tell me what would be the unit of this epsilon r? Yes, you're right. It has no units. Why? Because it is the ratio between the two similar quantities. Both are the permittivities. And what is the unit of permittivity? Yes, Coulomb square per Newton meter square. So epsilon is the permittivity of that medium, is in Coulomb square per Newton meter square, and epsilon naught is the permittivity of free space. Again, its unit in SI system is Coulomb square per Newton meter square. So this epsilon r becomes dimensionless. This is dimensionless. Okay, now if we write this equation in the form of epsilon r, or in terms of epsilon r, so equation 5, we can write that equation 5. Equation 5 can be written as F medium, that is when there is medium between the charges, is equal to 1 over 4 pi. And now at the place of epsilon, the permittivity of the medium, from this formula, you can see that if you find epsilon, then epsilon is equal to epsilon naught into epsilon r. So replacing epsilon by epsilon naught, epsilon r, epsilon naught, epsilon r, and q1, q2 divided by r square. This was equation 5. Now we have replaced this epsilon by epsilon naught, epsilon r. So F medium is equal to, just bring out that epsilon r out of that, to 1 over epsilon r, and within bracket this becomes 1 over 4 pi epsilon naught q1 q2 over r squared. So what is this within the bracket? Yes, this is the force, the electrostatic force between the 2 point charges when there was vacuum. So replacing this, F medium is equal to 1 over epsilon r into F vacuum. Now students, this is very, very important equation or formula, whatever you say. And we usually know the value of epsilon r. Now there is a table which is given in your book as well, that is for epsilon r, for the dielectric constants of different media. And from that table, you can also see that epsilon r is always greater than 1. That is, as it was the ratio, So whenever you compare the permittivity of the medium with the permittivity of free space, then the value of epsilon r will always be greater than 1. So from this we can see that if epsilon r is greater than 1, then whenever there will be a medium between the charges, then the electrostatic force will decrease. For example, we consider the example of sodium chloride. Sodium chloride, it has sodium positive ion and negative ions. They are strongly attracted with one another due to these ions. There is force of electrostatic force of attraction between them. So when you add some water in that sodium chloride, or when some salt is added in the water, that salt dissolves in water. Why this happens? This is because of the permittivity of water. The dielectric constant for water is approximately 81, which is 80 times greater than air or vacuum. So when we add some water in the, when we add some sodium chloride, that is salt, in water, that salt dissolves in that water because of this relative permittivity. This dielectric constant of water will reduce the force between the positive sodium ions and negative chlorine ions, and due to this reduction in the force, due to this, that sodium chloride dissolves in water, that salt dissolves in water, and it collapses that crystal structure. So students, from this equation we find that whenever there is a medium between the charges, that electrostatic force will decrease. And formula tells us that how many times that electrostatic force will decrease. As I have given you the example of sodium chloride. When that sodium chloride is added in water, then how many times that electrostatic force between positive ions and positive sodium ions and negative chlorine ions will decrease? Yes, 80 times. 80 times that force will decrease, which collapses the crystal structure. So now the next question is, formula wise we can see that electrostatic force will decrease because epsilon r is always greater than 1, and it will decrease this much time. But as a science student, the question is why that electrostatic force decreases when there is a medium between the charges. So dear students, we'll discuss this, the decrease in the electrostatic force, in our topic polarization of dielectric, inshallah, in the incoming lectures.